This is Chris. He's a proton, but Chris is not alone. There is also Maria, a neutron. They have a lot of neighbors, also protons and neutrons. They are part of an atom, to be more precise, of an atomic nucleus. Protons and neutrons are very social. They like having electrons around them. However, electrons are not as social. You could say they have a very negative attitude. Therefore, they don't live in the core with the protons and neutrons, rather in something we call an electron shell. They spread as far away from each other as possible, even into different shells if there is not enough space. That's the reason why atoms have more than one electron shell, depending on the type of atom. Here we have a carbon atom. Although electrons are not very social, they don't want to be completely alone. They feel most comfortable when they are located in their shell with a certain amount of other electrons. We call that a full shell. If they can't fill the outermost shell with their own electrons, they bond with other atoms to get a full valence shell. So, our carbon atom does not want to be alone. That's why it binds to another atom. This bond can either be a sigma or a pi bond. The distance between the atoms depends on the number of bonds. The atoms forming double and triple bonds are always closer to each other than those forming single bonds. Due to its reactivity, our carbon is very willing to react with other molecules and can therefore form various important structures like a carboxylate, an ester, an ether, or a carboxylic acid. In order to form a new bond to an atom in another molecule, a certain binding energy needs to be overcome. The unit of this binding energy is kilojoule per mole. If you take into account the mesomeric and the inductive effect of the already existing substituents bound to the molecule, you can even predict at which position of the molecule the new bond will form. We will have a look at the terephthalic acid, which is here combined with ethylene glycol, demonstrating a typical esterification. A proton attaches to the oxygen, resulting in a positively charged carbon atom. The electron-rich oxygen from the alcohol of the ethylene glycol attacks the electron-poor carbon. Now, the oxygen carries a positive charge. Under water elimination and subsequent deprotonation, the ester is formed. In order to accelerate this process, we use a catalyst resulting in a lower activation energy. In this case, we take manganese trioxide. In a few seconds, the product is ready and can be bottled. I would imagine you know the product of this reaction very well.